Okay. Hey, welcome back. Let me get in the way of the window here. Uh, so, if you recall, last time we had some molecules. So, I hope you have your molecule kit. It's falling apart, but this is what it looks like. And so, remember, we had our molecules and we broke everything apart. So, I want you, if you haven't done it already, take your molecules and break them apart. So, we have breaking apart all these bonds. This is what a chemical reaction is we're breaking bonds. So we have the methane, we totally broke it apart now. We have breaking them apart, put in sound effects like this. Okay, so they're breaking apart. And now, if you look down here, I have a mess of atoms. And what we do, so if you recall, over here, let me just get a pot. So I have my methane down here, and I'm going to light it on fire. And we can see we make this right here. That is water vapor, okay? We also make carbon dioxide. I can't see the carbon dioxide, but we know it's there because we tested for carbon dioxide using BTB, bromethymol blue. And so we need to now make water and carbon dioxide. And so those elements come from what we just broke up. We have everything we need. So I need you to take your elements and let's make our water molecules first. Water is H2O, and so I have an O. I'm going to take a bond, go ahead and jam it in there. And H, okay. That's H2O, so we're going to stick two of these in here, like this. Now H2O, that's one. Well, I have two more H's left over. I can make another H2O. Okay, so I'm going to go ahead and make another H2O right here. And now, what's left over? Well, we have one carbon here, and we have two oxygens, and that is just enough to make carbon dioxide, CO2. Oh, my stuff's falling apart. Okay, so we're going to make a CO2 now. Put this here. So C in the middle. And what's happening is we have these bonds, these atoms, they don't want to be apart. Remember, I see myself. So if we're looking at the simulation, we pull these atoms apart, and now these atoms are floating around. These atoms don't want to be apart. They want to be together, and they push back together. They snap back together again. I know that this is not really snapping back together, but imagine that atoms being apart, and they don't want to be apart. They come back together. Together. Just like magnets don't want to be apart, they want to stick to something else. So we're going to take this, stick it together, and snap together, okay? And now what we're going to do is we're going to look at the simulation and see, well, what happens to the energy when all these things, what happens to the energy, the potential energy between the atoms as they start snapping back together? What happens to, am I going from a higher to lower or lower to higher energy? What's going on with the energy when they snap back together? So remember, we have our molecules and they've broken apart. All the atoms are flying everywhere, and now they're joining back together. So we made this water molecule. Remember, water is hydrogen and oxygen. So we have a couple of those bonds. and they're forming back together. And so I need to make a hydrogen and oxygen. So I'm going to make sure that you have this set up so that you have both atoms. And now they're going to start coming together. Okay, so I'm going to move this in, and we can see what's the energy, what's going on with the energy. So we start, remember when we start far away, what's the level of the energy at? And as we bring them closer and closer together, what's happening to that energy as we drop down to this point, the balanced point on the graph? And so we look at that and see, well, where is that at now? And kind of measure out, you know, that's maybe around 3.8. Okay, so what's happening when I pull them together? Is the energy increasing, or am I releasing energy? Am I dropping down energy? So that's really what I really want you to be thinking about. Same thing when I make carbon dioxide. So carbon dioxide is, I'm going to take carbon and oxygen. Okay, so carbon, I'm going to start way out here. Remember, my carbon and oxygen are way far apart, and they're floating around, and all of a sudden they just kind of start snapping together. So carbon and oxygen making carbon dioxide. I bring this together. This is coming in like this, and now you see that is forming way out here. So it's much, but the amount of energy is about the same, you know, about 3.8. So they're coming together, and now remember what's happening to the energy. Is the energy going up or going down when I start snapping together? So when they're apart, they're out here like this, and now I bring them closer and closer together, and they go down like this. So what is happening to energy? And then we're going to take those energies in the table on the Google Doc and start figuring out, well, what's happening with all the amounts of the energies as we're doing this. All right, so as you get through the video and start working on the assignment, let me kind of walk you through this page here. So this page is a little confusing, but we're mainly looking at the things before the reaction and the things after the reaction. So before the reaction, we have methane, this molecule right here, and we have oxygen. We had two molecules of oxygen, which is O2 and O2, so two of these groups. And if you scroll down to this part of the document, now we're looking at how much energy each of these bonds has. So I'm going to do one of these for you. These are rough numbers, but just kind of get an idea of the energy needed to take to break a bond, or the energy that is changing as we are forming a new bond. So the CH bond, and I will also have a link on this to get to this simulation again if you want to do it yourself. But remember, this CH bond meets down here. So when they're far apart, the atoms are out here. When they are close together, they're here. And this is where they are bonded. So now we're going to break them apart. So how much energy is that? Well, we're going to take this, and this is at about -4, but we're going to ignore the negative numbers and just go 4 joules here. So I'm going to type in 4 joules. And is the energy increasing or decreasing as we do this? So as we break the bond, we start at the bottom part. Remember, they're together. And actually, I have this atom right here. So we have this right here, and we're going to take this, and it's at the bottom right now, and we're going to break it like this. And so that is separating them all the way out here. And so I start down here, and I'm going higher in energy, which means I have to put in energy to break this bond apart. So energy goes in. Okay, so I'm going to type that in there. And then now I gotta go, how many bonds is that? Well, I'm gonna look at the picture. So look at the picture here. CH4 has 1. This is a CH bond. This is 2, 3, 4. So total number of bonds here, what I'm going to do is type in the 4 bonds. And so the total energy it takes to break all these apart, I have 4 joules here times 4, because there's 4 bonds. And so that gives me a total of 16 joules. Okay. So now you're going to do this for oxygen. Oxygen's up here. Do the same thing. Count the total number of bonds. Look at this graph to see where is it approximately on the graph. Or ignore the negative numbers. And then when you have this number here, and whatever this number is here, okay, you're going to take these numbers and add them up and type them in right here. So what's the total energy it takes to break all these bonds apart? Now, as I have these atoms separated, they have to come back together. And so we form new bonds. Do the same exact thing. So what I did was I took the bond energies from the simulation again. If you want to do it again yourself, I will give you a link. But the OH bond, these are all, these things here is an OH bond. So there's an OH bond here, it's an OH bond here. I have 1, 2, 3, 4 OH bonds. Okay, so get that energy. Now I'm making a bond. Okay, so I start out here, right? So the atoms are out here to begin with. And as I bring them closer together, what's happening to the energy? So the energy now, you can see it's dropping energy. So this is what we call, we're releasing energy as we form this bond here. So I am going to say, well, now I'm forming, so energy is coming out. Energy being released, coming out. Okay, count the bonds in the picture up here. You can see how many bonds total there are. Multiply those out and get this number. Same thing with the CO bond. I have CO2. Well, I'm making this bond here. I'm making this bond. So count those, get this energy here, figure out how much the total is in terms of total number of bonds I'm making. And then once you have this number up here and you have this number up here, add those up, okay, and get this total number down here. Okay, this plus this, give me a total energy. And then I want you to be thinking about, well, did I put more, does more energy go in or does more energy come out?